In this lecture, we look at the intensity of sound waves. The intensity is the rate at which energy per unit area is transferred to a surface. Let's look at a picture of this to see to make this a little bit more clear. The intensity is the number of yellow packets of energy that are striking the blue surface per second. So as a packet of energy, whatever it is, strikes the surface, so it's defined by the area of the surface and by the rate at which these packets arrive at the surface. The units of intensity are joules, energy, divided by meter squared, the area, divided by seconds, the rate or the time, the rate at which it's arriving, or also watts per meter squared. Generally, sound intensity drops as the distance from the source grows. It falls off typically by like 1 over r squared. This comes from this analysis. Imagine a point source with a power P sub s. We're going to listen to this sound source a distance of r away from it. If we draw a sphere around this point source, which has a radius of r, then the intensity falls off like the power of the source divided by the area of the sphere, 4 pi r squared. So that's where the 1 over r squared fall off comes from. Sound intensity is usually described in comparison to our threshold hearing level. This level is 1 times 10 to the minus 12 watts per meter squared. So our hearing is very sensitive and goes over a very wide range. So sound level is usually not given in terms of a linear system, but rather in terms of a log system or in terms of dB, where you take 10 dB times the log of whatever intensity of sound we're talking about and divide by the threshold hearing level. Here's a few examples of sources. We see that the Russell of Leeds has a sound level of around 10 dB. Conversation has a level of about 60 dB. A rock concert has a level of 110 dB. And the pain threshold for hearing is around 120 dB. So sounds have a range, go over a range of about 10 to the 12th. Let's look at an example. Let's consider a firecracker that explodes, releasing 500 joules in about a half a second. How far do you have to be away from this to not have it exceed the pain threshold? Let's look at the power of the source. So the power of the source will be equal to this 500 joules divided by the half a second in which the energy is released. So that's about 1,000 watts. Then the intensity as a function of distance is given by this I of r that is equal to this power of the source divided by 4 pi r squared, where r is the distance away that we're listening. The sound level of your pain threshold is 120 dB, or 10 to the 12th times the hearing threshold of 10 to the minus 12 watts per meter squared, or this I pain is equal to 1 watt per meter squared. Now let's take this function, the intensity is a function of distance, and rewrite it in terms of solving for r squared. So we have r squared is equal to the power of the source divided by 4 pi divided by the intensity as a function of r. R pain then is equal to the square root of this power source divided by 4 pi divided by I pain. This is coming from the pain threshold value. We plug in all the numbers and take the square root. We get 8.9 meters. So you have to be about 30 feet away from the firecracker so it doesn't exceed the pain threshold.